welcome again to Maths with Bob. Today we're looking at Simpson's rule, the multiple applications of Simpson's rule actually. It's called the general rule, where we have more than one application of Simpson's rule. You'll see in a previous video we just did one application when there was two strips. Now, okay, so what would we normally do? We would try and estimate the integral from a to b of fx dx, okay, by adding up lots of strips values with parabolic tops. Now we have the h, which is the width, divided by 3. We have the first and the last function values. So we're adding these together, first and last. We then look at 4 times the sum of the odds. So sum odds, and then plus twice the sum of the evens. Now, this does presuppose we start at y0 and finish at yn. Okay, being n strips. Okay, so in this case, let's have a quick look. Here we go. Okay, let's draw up a function. Okay, here we are. Let's call that y0, y1, y2, y3, y4, y5, and y6. Now you see we have to have even numbers of strips for Simpson's rule. Okay, so let's actually have a quick look. Okay, the first one. Well, the first one's here, and the last one is over there. Right, they're the heights we'll be looking at. Now the odds. Which one are odds? Okay, so let's actually get some odds. The odd ones. Okay, so the odd ones would be this one. That's 1, and this one would be odd, and this one would be odd. Okay, now the evens, let's have a look at the evens. Okay, the evens would in fact be 2 and 4. Okay, so there'd be the even one. So we just had to put all these numbers in. Now h, what is h? Well, we can see here h is actually just this width. Now, if we can't see h. Well, h is actually obviously the width of each strip. We can do b minus a on n. But normally, if it's actually a mystery function, which we're going to look at in a minute, you can actually tell directly just by looking at the function values. Okay, so let's do an example. Okay, let's here we have some function. Okay, now let's have a look at, here we are, y0, y1, y2, y3, y4, y5, and say y6. Okay, that should be enough. Okay, so we have 6 strips. Okay, now what we'd then do is we'd have to actually look at the heights over here. Some of them may be the same, so let's just assume they're the same. Let's just assume these two are the same as well. Okay, and maybe you could even assume that these two are the same. Okay, so what you'd normally be given is a table of values, okay, with ordered pairs in it, the x values. So let's call that 1, 2, 3, 4, 5, 6, and 7. Okay, you can see the width is 1 automatically. Now, if that was, say, 2, 4, 6, 8, 10, obviously the width would be 2. Now, let's just make up some heights, okay? So make that 10, 12, 14, and say 16. Now, we are obviously assuming everyone knows this is the y-axis, this is the x-axis, the function. I need to basically label our axis usually. Here we are. Now to apply Simpson's rule with multiple values, we remember it's integral from a to b of this mystery function. Now, this is the actual mystery function here. Mystery function. Now, the reason I call it a mystery function is because you won't actually know what the function is. The actual table of values will be just given to you, and you'll just be having to assume that this is following some sort of functional rule. Now, we just call it like this. Fx dx is approximately equal to h on 3. We can still have a quick look. H is obviously, you can see here, 1 unit. Okay, so it's 1 over 3. Now it's y0, which is in fact height of 16. So let's just put it in y0. I'll just put it in y0 plus y6 plus, you can see here, 4 lots of the odds. y1 plus y3 plus y5 plus twice the sum of the evens, y2 plus y4. Okay, so this is the rule. We've already substituted h in, but let's actually plug in some numbers. Okay, 1/3. Okay, y0. You can see here y0 is actually 16. The first one is 16. This one is y0. 16 high. The last one on the end here is actually only 14 high. Okay, now we have to 4 times. Okay, now y1 is 14. y3, you can see here's only 10, and y5 is 12. Plus twice. Okay, let's have a quick look here. y2, you can see here is 12, and y4 is 10. Okay, so here we have the approximation, and we just have to work out this. So we have, see what we've got here, 30 plus 4 lots of 10, 20, 36, and then we've only got 2 lots of 22. Add all this up, I think we get 218, so it becomes approximately a third of 218, which I think works out to be approximately 72 and 2/3. Okay, so that worked out to be, I think, in 218 when we added all that up. Okay, well, this is actually, you can see multiple applications. Now this is actually the mystery function. Sometimes you're actually given a function. So let's actually have a look at one where you're given a function. Okay, so let's suppose we are given a function like, say, okay, y equals, say, x squared plus 1, and we have to try and work out Simpson's rule giving, say, 6 strips. So let's have a look at Simpson's rule, say 6 strips. Okay, so I always like to draw up a picture, and we know this one's a nice little parabola. Okay, 6 strips. Okay, let's go from, say, x equals, say, 1 to 7. Okay, so we know this is 1, so we're going at 1, 2, 3, 4, 5, 6, 7. Okay, so the heights will be, let's have a quick look at the heights. Okay, at 1, now how do we work out this height here? Well, we have to put it into the function. So function of 1 is equal to what? 1 squared plus 1. Function of 2, obviously, is actually 2 squared plus 1. Function of 3, etc., is 3 squared plus 1. Okay, so let's actually just work out these values on the side here. So 1 squared is 1 and 1 is 2. This one will be 2 squared is 4 and 1 is 5. Okay, 3 squared is 9 and 1 is 10. 4 squared, okay, 16 and 1 is 17. Okay, 5 squared, okay, 25 and 1, 26. Going up here a bit higher. Okay, 6 squared, 36 and 1, 37. And right at the top here we have 7 squared, 49 and 1 is 50. Okay, so we've just gone a bit beyond the graph here, so I'll just sort of, okay. Okay, so here we have a function which we've given. We know what it is, x squared plus 1, and we can actually work out the particular heights ourselves. So let's actually work out what Simpson's rule is. Okay, and so we know that, okay, well, okay, so we want to integrate from, say, 1 to 7 under x squared plus 1 dx, and we want to work out using Simpson's rule. Okay, so we know Simpson's rule is h on 3, okay, well, in this case it's y0, which is, okay, let's just write y6 plus, okay, 4 lots of y1 plus y3 plus y5 plus 2 lots of y2 plus y4. Okay, now which ones are the y's? Let's actually, you should be able to see here. Okay, this is y0, y1, y2, y3, y4, getting a bit harder, y5 and 6 over here. So these are the actual heights. So let's put them in, okay. So we can see the width too. The width is 1. Okay, the width here. So h is equal to 1. Okay. So okay. So it's approximately what? 1/3. Now, what do we have? We have 2 plus 50. So the first and last. 2 plus 50 plus 4 lots of y1, y3, and y5. Be 5, 17, and 37. 5 plus 17 plus 37 plus 2 lots of y2 and y4. So these are the odds. Actually a bit hard to read. These are the evens. Okay, y2 and y4, which are 10 and 26. 10 and 26, okay. All right. So let's put all this in. We have approximately 1/3 of, okay, it's 52, 236, and 72. It's approximately 1/3 of 360, which is approximately equal to obviously 120. Now, that actually works out, that actually is the exact value if you do it by the fundamental theorem of calculus. Okay. Thank you for watching. Bye.